Hello. Today we're going to be looking at the exam for Chapter 5. This is the practice exam, but it's very similar to the exam that you'll actually be taking in my class. In Chapter 5, we're studying rational expressions, which are expressions that are fractions, but there's going to be variables involved, so it's kind of a difficult topic to deal with because you have fractions, you have variables, you have factoring. And so we're going to take a look at several examples here from the chapter. So for this first example, we're asked to simplify by removing factors of 1. That just means canceling out common factors from the top and the bottom. The key word here, the important thing, is we're talking about factors, right? So you can only cancel out factors, so keep that in mind. Meaning we can't cancel out these 15s because this 15 is not a factor, it's a term. Factors are things that are being multiplied together. Terms are things that are being added or subtracted, right? So 6y is a term here, 15 is a term here. You cannot cancel out just terms. You can only cancel out things that are factors, that are being multiplied to everything else. So if I want to be able to reduce this or simplify it, I need to first factor it and see what the factors are, and then I can cancel out any common factors. So what I can do with the numerator here is not much, but I can factor out a common factor of 3. So I'll factor out a 3. And I'll be left with 2y minus 5 on top. And on the bottom, there's not much I can do to factor the 15. I guess you could write it as 3 times 5 if you wanted to factor it as a number. And notice that on top we have a factor of 3 now. So let me say it this way. Sorry. 3 is a factor, and 2y minus 5 is the other factor here. So these are my two factors. Since 3 is now a factor, I can cancel it out with this 3 on the bottom. And that's going to leave me with 2y minus 5 on top and with a 5 on the bottom. And so that would be my final answer. That's what you would type into Math Excel. Be careful when you're typing this in, that as you're typing it into Math Excel, which is, my math lab, same difference. If you type it in like this, if you go 2y minus 5, and then you hit the fraction key on the keyboard, which is the slash symbol, what's going to happen is Math Excel is going to interpret it like this. It's going to go 2y minus, and then 5 will be on top of your fraction, and then it'll give you a little denominator here where you could write your other 5. But that's not the way it needs to be typed in. The 2y needs to be on top as well. So you can either use parentheses here to make sure the whole thing stays together when it sets it up as a fraction, or use the fraction button at the bottom. There's some math symbols at the bottom. You can use the fraction button, and then you could type in 2y minus 5 here and type in 5 on the bottom separately to get it into Math Excel correctly. All right. Same thing on this one. In order to simplify this, we need to first factor it. The x squareds do not cancel out because they are terms. You cannot cancel out terms. We have to look for factors. So we have to factor the numerator here, and this goes back to the previous chapter, Chapter 4. We need two numbers that multiply to 6, but add to negative 5, and that will be negative 3 and negative 2. Right? Negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 is negative 5, so that's how the top one's going to factor. We do the same thing on the bottom. Two numbers that multiply to negative 12, but add to positive 4 will be positive 6 and negative 2. Right? And so that's how the bottom one's going to factor. And then we see after we factor it that we have a common factor here. We have an x minus 2 on top. We have an x minus 2 on the bottom. These are factors, so as a whole, they can be canceled out with each other. I'm not individually canceling out the x's or canceling out the 2's. It's all or nothing. Either the whole factor cancels out or nothing of it cancels out. What I'm left with is an x minus 3 on top, which I don't need parentheses around anymore, and an x plus 6 on the bottom. All right, and so that's what you type into Math Excel. For multiplying, it's really no different than the problem we were just doing. First, you want to factor everything, because in order to get a simplified answer, we need to know what the factors are so we can cancel some things out. And the neat thing about multiplication is that you can cancel things out before you multiply, right? So normally with most mathematical operations, you have to do the operation first and then you can simplify. But with multiplication, it's a special one. We can simplify first. We can cancel things out first and then multiply whatever's left over together. So the first step here is to factor everything. Everything needs to get factored here. So the y squared minus 49, that's another type of factoring that we had in chapter 4. It factors using this formula here, a squared minus b squared. That's going to factor as a plus b, I don't know why I put x, and then a minus b, right? In this case, instead of a, we have y, so it's going to be y plus 7, y minus 7, right? And instead of b, we have 7 here, because 49 is 7 squared, right? So we plug in 7 for b. On the bottom, it's just y squared, which you can't do anything with. You can't factor it, which means it's its own factor. Y is the factor down here, and it can be canceled out if we find another factor of y, which we do in the next numerator here. So y squared minus 7y, don't overthink this. The only thing you can do with this is factor out a y. It's a common factor, and that's all there's going to be to that. So we factor out a y, and we'll be left with a y minus 7. And then on the bottom here, it's back to the previous example like we were doing there. Two numbers that multiply to negative 63, add to positive 2. That's going to be positive 9 and negative 7. So that's how that one's going to factor. All right, so that's the first step. Factor everything. Then we can cancel out common factors. The only stipulation here is that one of them has to be on the top of a fraction, the other one has to be on the bottom of a fraction. It doesn't have to be the same fraction. And so, for example, I can cancel out this y minus 7 over here on the left-hand side with this y minus 7 on the bottom on the right-hand side. As long as one's on top and one's on the bottom, they can be canceled out. Same thing here. This y can be canceled out with one of these y's here. So think about this. The exponent of 2 means you have y multiply to itself twice. We can cancel out one of them, and so we'll still have one left over. All right. And that's it. So not much else is happening here. Unfortunately, not as much cancels out as we might have hoped. So you cancel things out, and then the last step is multiply together the tops and the bottoms. So how you multiply fractions is you multiply the numerators together, you multiply the denominators together. Right, and so on top we're going to have the y plus 7, which we need to keep in parentheses, times the y minus 7 over here. And on the bottom we're going to have, there was a y left over from this denominator, so y times this y plus 9. All right, so when you multiply fractions, you do not need a common denominator. All you do is you multiply across. You multiply the numerators together, multiply the denominators together. So I'm just taking whatever's left over here and multiplying these things together, right? Y and y plus 9 on the bottom, y plus 7, y minus 7 on the top. And I think you can leave your answer like this. I know it says simplify your answer. Simplifying is really referring to the reducing that we're doing here. I think it's okay to leave it like that. If not, you would just multiply it out. So you might want to kind of test this out. You should have seen problems like this on the homework for one thing, but if it's getting close to the test, do the practice exam, and then you can test it out on there to make sure it's going to accept the answer in this form. If it doesn't, you just have to FOIL here. So y times y would be y squared. Y times negative 7 is negative 7y. 7 times y is positive 7y. And then 7 times negative 7 is negative 49. That's what you get on top. On the bottom, you just distribute the y here, and you'll get y squared plus 9y. And so if they ask you to simplify it like this, here the 7y's cancel out, so you get y squared minus 49 on top, and on the bottom you get y squared plus 9y. And so that'd be acceptable as well. I really think this should be okay, but if not, this is the way you would need to type it in. If on the test, after you submit it, you type it in like this, and it tells you you're wrong, email me. I will go and correct it. I will give you credit if you have your answer in this form. All right, just need to email me and I'll restore your points. All right, this one is almost the same kind of thing, except here we are dividing. So be careful to notice what's going on there. The directions spell it out for you. And dividing is almost the same thing as multiplying. You just have to do one thing first, and then it just becomes a multiplication problem. You're going to multiply by the reciprocal of the second fraction. So I'm just going to rewrite this problem. 64b squared minus 49 over b squared minus 1 times we'll put the b minus 1 on top and the 8b minus 7 on the bottom. You multiply by the reciprocal. Now it's a multiplication problem, so we do the problem just like the previous example. You're going to factor everything first. Notice again we have the a squared minus b squared. That is a favorite in chapter 5 to have that kind of factoring using this formula here. This time instead of a we have 8b, right? It's 8b getting squared here. And instead of b we have 7 being squared. And so this one will factor as 8b plus 7 times 8b minus 7. So that's what we get on top. For the bottom one, it's instead of a we have b, and instead of b we have a 1, right? Because this is the same as 1 squared. So this will be b plus 1, b minus 1. Right? The fact that it's a b here makes it kind of confusing because there's a b in the formula that we're using as well, right? So make sure you're not getting those confused. Times b minus 1 can't be factored. It's too simple to factor, which means it's its own factor. B minus 1 is the factor here. There's no other factors except for b minus 1. Same thing on the bottom. We have 8b minus 7. Since it doesn't break down into any smaller factors, that is the factor that we have in that denominator. So what we're going to do is we're going to cancel out common factors now before we multiply these two fractions together. And what cancels out in this case is we'll have a b minus 1 from down here canceling out with this b minus 1 up here. And then we have a 8b minus 7 on the top here canceling out with this 8b minus 7. If everything gets canceled out in a particular spot, a 1 is left over. Sorry, that was a horrible one. Let me try that again. A 1 will be left over here and a 1 will be left over here. All right. And so we multiply whatever's left over, we multiply those together. So on top, all we really have left over is the 8b plus 7, because times 1, right? So it's 8b plus 7 times 1, which is just going to be 8b plus 7. Same thing happens on the bottom. It'll be the b plus 1 times 1, which is just b plus 1. And since there's nothing else around it, we can drop the parentheses. And so this will be my final answer here. All right, let's take a look at the next example. Find the LCM. This stands for least common multiple, which is the same thing as a least common denominator. So essentially what they're asking us to find here is the least common denominator. And this one's kind of tough. I wish I would have taken a closer look at it before so I'd know what the answer is ahead of time. For these, you want to split these up into dealing with the numbers and the variables separately. So let's start with the numbers. We have 21, we have 3, we have 35. We want to find the least common multiple of 21, 3, and 35. All right. And so if you take that phrase literally, it's asking you to find the smallest, that's what least means, the smallest multiple that these three numbers share in common. So one technique you can use, especially if the numbers are getting a little hard to figure out, is you can make a list of the multiples of these numbers until you find the first one that all three share in common. So for example, let's do 35 first. So the multiples of 35 would be 35, 70, 105, 140, right? And it would just go so on and so forth. Hopefully that's going to be far enough for us. For 21, it's going to be 21, 42, 63, 84, 9, not 90. The next one will be 105, right? So let me undo that mistake. If you add 21 to that, you're going to get 105, which we happen to have over here already. Now, as long as 105 is a multiple of 3, we're going to be okay. But if I don't want to sit here and go 3, 6, 9, 12. So another way you could check is just divide. Does 3 divide into 105? So let's find out. 3 goes into 10 3 times. We have a 9. You get 1 left over from that. Bring down the 5. 3 goes into 5 15 times. So yes, 3 divides evenly into 105. So that means 105 would be a multiple of 3 as well. And so it is a common multiple, and it'll be the first one that all three of them share in common. All right. So for the number part of this, the least common multiple is going to be 105. That's actually the hard part. You might say, oh, now we have to do the variable part. The variable part's the easy part. So you look at the variable factors you have. Now they have to be factors, which means they need to be multiplied together, which these are, right? This is c times b, c times b. You take each variable factor that occurs. It doesn't have to be shared in common. They happen to be shared in common in this example, but it doesn't have to be. So any variable factor that occurs needs to be in my least common multiple. So I have c as a variable factor, and I have b as a variable factor. And while it might seem backwards, what you will do is raise each one to the highest power that occurs, right? And so even though it's a least common multiple, you want the highest power of each one. So when I look at the c's, the highest power of c is 8. And so I will use 8 in my least common multiple. And when I look at the b's, the highest power of b is 6. And so that's what I should use in my least common multiple. And that would be the common denominator for these three expressions, right? And so that's how that one works. Okay, let's take a look at the next one. Here we want to subtract. If you're adding or subtracting a fraction, you have to have a common denominator. These denominators are almost the same. They're close enough that we're going to actually be able to make this work, but they're a little bit off, right? So if I wrote this denominator around the other way. Now be careful when you're taking the test, because the problem is typed up here, and then underneath they copy the problem again and then put the equal sign, and this is where you're supposed to type in your answer. Don't think of this whole thing as your problem. That'd be very complicated. We will see some problems like that later, but just this is the problem here. We want to subtract these two fractions. It's just being copied again down here. Now if I take this denominator and switch it around to write it in the same order as this one, I'll have 6x minus 48 still over x squared minus 64 minus, this will still be 8 minus x on top. This, if I put the x squared first, will be negative. It's negative x squared, right, because of the minus sign. That stays with the x squared. And then a positive 64 will follow it, so plus 64. So these aren't really 100% identical. And if they're not 100% identical, it's not a common denominator, so you can't subtract these fractions. But they're really close to being the same, right? They both have x squared, they both have 64. The only difference here is these are the wrong sign. If I can switch the sign of these, this negative and this positive, switch those, then it matches up to this perfectly. Thankfully, there's an easy way to do that. You just factor out a negative. So I'm going to rewrite the problem, factor a negative out of this denominator, and so this will make this a positive x squared, and this will make this a minus 64 when I factor out the negative sign. Okay. The first fraction, again, we're not doing anything with, so I'll just copy it down. And what's going to happen here, I mean, it's a little bit of hand waving here, but this negative sign and this negative sign really combine together to make it a positive. When you have a negative sign as a factor, it's pretty mobile. You can kind of put it wherever you want. If it's a factor, you can either leave it on the bottom, or you can put it as a factor on top, or you can just stick it in front of the fraction, which is kind of what I'm doing here. And when you have a negative of a negative fraction, that's going to make it positive. I mean, the math behind that is more having to do with this. I can just multiply a negative 1 to the top and bottom, right? That cancels out the negative sign down here, and now it's on top, right? So it just kind of moves wherever you want to put it. So the negative signs will cancel out, and this will become positive, so we end up adding these fractions. So we're going to have 6x minus 48 over x squared minus 64. Again, these negative signs cancel out, and this becomes positive. We'll have 8 minus x on top, and on the bottom, since there's nothing else here now, the negative sign's gone, we used it up, it'll just be x squared minus 64, and we don't need the parentheses around that. Sorry, I forgot the 6. All right, so x squared minus 64. Now that we have a common denominator, finally we can go ahead and combine these fractions together. And let me put equal signs all throughout here. All right, and so what we're going to get is, here's the tricky thing. When you're adding fractions together, you have to have a common denominator. And in the answer, the denominator doesn't change. It stays that common denominator. So it's going to be x squared minus 64. So that'll stay the same. What gets added together are the numerators. So we're going to have 6x minus 48 plus 8 minus x. All right. Now we can combine. We'll simplify the top here. So we have 6x minus x, which will be 5x. And negative 48 plus 8 will be negative 40 over the common denominator of x squared minus 64. Now that was kind of a lot of work getting it set up. The next one's going to be worse than this, by the way, but because this one was basically already a common denominator, but the negative sign was tricky. It took us a little bit of time. Finally got it added together. We did all that work. Unfortunately, we can't just say, okay, we're done. We have to check to make sure the fraction can't be reduced. And the only way to check is by factoring. So unfortunately, we have to take the time to factor this. Now I'm kind of out of room over here, so I'm going to move the problem this way, and I'm going to factor it. Right? So let's take the answer that we got here, and we're going to move it over here. Sorry, I'm making a mess of things, but I'm going to factor. Now the numerator, the only thing we can do to factor this is factor out of 5. So I'll factor out of 5. We'll have x minus 8 remaining. On the bottom, it's the a squared minus b squared again. How many times have we seen that? So you guys want to make sure on the test you're ready to factor things that look like that, because you're going to see it a bunch. This will factor as x plus 8, x minus 8. So what do you know? We end up getting a common factor here that can be canceled out. Right? So I can cancel out the x minus 8s, and so this fraction does reduce, and we end up getting 5 over x plus 8 as our final answer. All right, so that's continuing down here, and we end up getting this. Most of the time, now if you go back to your homework for this section, most of the time after you add or subtract, you get an answer where it doesn't reduce. But there's that 5 or 10% of the time when the answer actually can be reduced, so we have to check every time. Can it be factored? If so, let's go ahead and factor it and see if something cancels out. If it can't be factored, it can't be reduced, right? I mean, if it doesn't factor, you're not going to be able to cancel anything out. All right, let's take a look at this one. Now what makes this problem challenging is that we do not have a common denominator, and it's not even close. There's no way for me to factor out a negative sign here to make these match up. We're just going to have to find a common denominator, plain and simple, and it's going to be a little bit of a challenge. It's going to involve doing the least common multiple. Before we find the least common multiple, we have to have these things factored. They have to be factored to find the LCM, and it makes it easier for getting a common denominator to have these factored. So we're just going to rewrite the problem with these factored, right? So we'll have 6z on top. That's not going to change. This will factor as we have to find two numbers that multiply to 55 but add to negative 16. And so that will be, it might take you a minute to think of, but it's going to be z, I don't know why they had to pick z here. I have trouble writing z's. It's going to be negative 11 and negative 5, right? Negative 11 times negative 5 is positive 55. Negative 11 plus negative 5 is negative 16, right? Minus, we'll have 5z on top here. This one kind of factors the same way. Two numbers that multiply to 66 add to negative 17. It's going to be z minus 11 again, but this time z minus 6 to get the 66. All right, so again, clearly these denominators are not the same. Unfortunately, we can't just subtract a 1 here to make this a negative 6. I wish we could do that, then they'd match up. That would be a lot easier, but fractions don't work that way. Factors don't work that way. So what we have to do is find the least common multiple of these two denominators. So we need to find an LCM, and that will be my common denominator. This time we don't have any numbers to worry about. We just have variable factors. So we take each variable factor that occurs. It doesn't have to be shared in common. So let me find all the variable factors that happen in these denominators. I have a z minus 11. Now that one does happen twice, but we only write it once in the common denominator. We have a z minus 5. It's not shared in common, but that's not a requirement. If it happens at all, it needs to be in the common denominator. So z minus 5, that happens over here. I need to put that in my common denominator. And z minus 6. That is a factor that occurs. It needs to be in the common denominator, even though it's not shared in common with both denominators. Then we raise each one to the highest power that occurs. But once you get to these kind of problems, most of the time, everything's just to the first power. And so for your common denominator, everything's going to stay to the first power. So it's just going to stay the way it already looks. So this is my common denominator. I need to get these fractions to match this common denominator. And since we have it factored, that makes it a lot easier, because what you're going to do is compare. Look at the factors that you already have. look at the ones that you need, and whatever's missing, you just multiply it in there, right? So this denominator already has the z minus 11, so that's supposed to be a check mark. Let me try that again. Whoops, hit the wrong button. Oh no, what did I do? I guess I can't erase it now, so I'm just going to have to try to fix it. Check mark, and it already has the z minus 5. So we already have those two factors. The one it's missing is the z minus 6. So I need to multiply it here so that it has that missing factor. I'm going to multiply to this a z minus 6. If I multiply that to the bottom, I got to multiply the same thing to the top. Right? That's how you keep fractions balanced out. It has to be multiplication, and you have to do the same thing to the top and the bottom when you multiply. All right, so what that's going to give me on top is I'll have 6z times z minus 6. I'll put that in parentheses. On the bottom, I'll have the common denominator, the thing I wanted, z minus 11, z minus 5, and z minus 6. All right, so I have the common denominator here for this first fraction. Do the same thing for the second fraction. What's missing from here is the z minus 5. Right, so let's do a different color here so it stands out a little bit. We already have the z minus 11. We already have the z minus 6. What we're missing from this denominator is the z minus 5. So that's what I need to multiply here. So I multiply z minus 5 to the bottom, so now it has that missing factor. But if I multiply it to the bottom, I have to multiply the same thing to the top. So what we're going to end up with is 5z times z minus 5 on top. And on the bottom, we'll have the common denominator. And I'm just going to rearrange this in the order of the LCM so that they match up to each other a little more closely. Technically, it doesn't matter the order you put the factors in, but it's nice when we have them both in the same order. So I'm going to put z minus 11. I'll put the z minus 5 next, and then I'll put the z minus 6. So now we have a common denominator. After all this hard work, we can finally subtract these fractions together into a single fraction. Remember how that works is the denominator, sorry, that was a horrible line there. Let's try it again. Oh, still pretty bad. Let's try one more time. Straighten that out a little bit. Okay, that's a little bit better. The denominator will stay the same, right? Once you have a common denominator, it stays the same in my answer. It's going to be z minus 11, z minus 5, z minus 6. And then what gets subtracted are the numerators. Right, so it'll be this 6z times z minus 6 minus 5z times z minus 5. So now I've done what I was setting out to do. I've subtracted these two fractions into a single fraction. But you can't leave your answer like this. We can simplify this by distributing the 6z and the 5z, and then combining like terms, and then checking to see if we can reduce it by factoring. Right, so what we're going to get on top is we'll end up with 6z squared minus 36z when we distribute. Now, here's the thing you got to be careful about. You might have said, well, why don't you just go ahead and distribute up here at the beginning, or like up here, since you know that you're going to have to do that. That's fine. This part would work out the same. But if you distribute the 5z early, and you got 5z squared minus 25z up here, and then you copy that down to here, you might make a mistake because the minus sign also has to be distributed to this expression. And a lot of students will miss that. So what I like to do is I like to wait. And once I get to this point, when I go to distribute the 5z, it's obvious to me the negative sign should also be distributed with that, so I won't make that mistake with the negative sign. So I get minus 5z squared plus 25z is what I should end up getting here. Over the common denominator of z minus 11, z minus 5, and z minus 6. All right. So I'm going to continue over here since I'm running out of room. Combine like terms. 6z squared minus 5z squared just gives me 1z squared, which I'll just write as z squared. Negative 36z plus 25z is going to be negative 11z. So what do you know? This is going to be one of those 10% times where it actually is going to reduce. But this one, at least it was kind of easy to see. You know, we didn't have to do any like really tough factoring just to find out it doesn't reduce or that it does reduce. So I see here that I'll have a common factor of z, so I'll factor that out. And I can see pretty easily what's left over is going to be the z minus 11, which I happen to have on the bottom as well. So this one actually reduces. This is why you have to check. Now on the test, you might get one where it doesn't reduce, but you still need to check by factoring. Otherwise, it won't count it correct, right? And so let me pick a different color here. So I have z minus 11. Those cancel out. So my final answer here is going to be z on top. That's all that's left on top, over z minus 5 times z minus 6. And you should be able to leave your answer like that. All right, so if that scared you, it probably should scare you. It's a tough problem, but it only gets easier from here, in my opinion. I mean, not that I don't want to say the rest of these problems are going to be easy, but this is by far, I think, the toughest problem in the chapter. I think it's more difficult than the word problems. So you might disagree with me on that, but this is a really tough problem. So don't feel bad if you're having trouble with it, if it's hard to follow. That's to be expected. These are pretty difficult problems. All right. So let's take a look at this next one here. So this one I think you'll find, kind of a nice change compared to that last one. So here we're being asked to divide these two polynomials. If the thing you're dividing by is just one term, like this is here, right? There's no other adding or subtracting, so it's just one term here. We have a shortcut we can use. So we should use this shortcut, and that shortcut is to set this up as a fraction. So take the division and set it up as a fraction. So on the top we'll have the 18, a to the 7th power, b to the 8th power, minus 16, a to the 5th power, b to the 6th power, plus 14, a squared b. The whole thing will get divided by 2, a squared b. Right? So that's going to go in the denominator. And the shortcut is take the denominator and divide it individually into each term of the numerator. So basically we're taking this one fraction, splitting it up into multiple fractions where the common denominator is 2a squared b. Right? And so we're going to get 18, a to the 7th power, b to the 8th power. Sorry, I must have accidentally hit the erase button. Over 2a squared b, right? Whatever that denominator is. Sorry, it's really hard to avoid on this pen, not hitting the... So there's a button on the pen I'm using that I think is by default set up to erase instead of write. And it's sometimes hard to hold the pen without pushing that button. So forgive me, all right? So we have the 16, a to the 5th power, b to the 6th power, divided by the same denominator, 2a squared b, plus 14, a squared b, over the common denominator, 2a squared b. And by splitting it up like this, we can simplify or reduce each individual fraction. They're all multiplied together, so they're all factors, so everything is fair game to cancel out. So I'll reduce the 2 here with the 8. That'll leave me with a 9. Cancel out 2 powers of a, so I'll have 5 left over here. And it's 1 power of b, so I'll have 7 powers of b left over. So this result simplifies down to 9, a to the 5th power, b to the 7th power. Minus the 2 cancels out with the 16, leaves me with an 8. 2 powers of a get canceled out. 1 power of b gets canceled out. And we get 8. Sorry, I don't know why I skipped the a. 8, a to the 3rd power, b to the 5th power. Plus the 2 cancels out with the 14, leaves me with 7. Both powers of a cancel out. The b's cancel out. And so we just have 7. And that's divided, so that will be my final answer. Again, that shortcut only works if you're dividing by just one term. If it's just a monomial, then you can do this. If it's not a monomial, you have to do what we're about to do here, which is long division. All right, so if you're dividing by something that has more than one term, like in this case, the thing we're dividing by here has 2 terms. So we can't use that shortcut on the previous example. We have to do this by long division. So we're going to take the thing we're dividing by, which is the 6w plus 3, divided into the thing we're dividing into here, which has a name. I'm just trying to avoid using it, but I shouldn't. It's called the dividend, right? So the thing we're dividing into is the dividend. That needs to go on the inside. So we have 42 w to the 3rd power plus 9w squared plus 36w plus 25. All right, took a little more space than I thought it would. Okay, so what we're going to do is we're going to ask ourselves, what do we multiply to the first term here so that the result we get matches the first term here? So more specifically for this example, what do I multiply to 6w so that I get 42w to the third power? So to get the 42, I need to multiply a 7 to the 6. So I'm going to choose 7 for the number. And to get the w to the third power, I already have one w here, but I need 2 more to get 3, right? So I need to multiply by a w squared. So I'm going to multiply by 7w squared to this 6w. That way it matches this first term here. So whatever you're going to multiply by, you put that on the top. Now, while I was focused on the 6w to figure out what I wanted here, whatever I end up choosing has to get multiplied to both of these terms. Has to be distributed to both of the terms in your divisor. So we get 7w squared times 6w, which gives me the 42w to the third power. Right, so it matches that first term completely. That's the important thing. But then we also get 7w squared times 3, which will be 21w squared, which we write underneath this w squared here. So make sure your like terms are lining up here. That's really important for this to work out nicely. So that's getting as close as we can. Then what we want to do is subtract to find what's left over that we still need to deal with. So I want to subtract this, but when I go to subtract this expression, I have to subtract the whole thing, which means the minus sign has to be distributed to both terms. So not only subtract the 42w to the third power, we also want to subtract the 21w squared. So that becomes negative as well. So we subtract. What should always happen is the highest power of the variable, in this case w, should cancel out, right? So these cancel out. What's left over here is 9 minus 21, which will be negative 12w squared, right? You're combining like terms, the variable part stays the same. And this time it's a negative that's left over. And so that's what we're left over to deal with for the next round. To start the next round, we'll go ahead and bring the next term down, which is the plus 36w. And you basically just repeat the process we just went through. What do I multiply to 6w to match the first term here, which is negative 12w squared? So to get negative 12, I would need to multiply by negative 2, right? Negative 2 times 6 is going to give me the negative 12. And to get the w squared, I need another w here. W times w gives me the w squared. So this will be my choice. I'm going to multiply by negative 2w. But whatever I choose to multiply by, I have to make sure to multiply to both of these. So we get negative 2w times 6w. That's going to be negative 12w squared. And then negative 2w times 3, which is negative 6w. And don't forget, it's an easy step to forget. A lot of students remember it the first time around and then they forget for the rest of the problem. You have to subtract this from what's above it to find out what's left over. So subtracting this means distributing a minus sign to both of these. So these both will become positive, right? They were both negative. So essentially they just switch signs. That's what a lot of students remember is, then I switch the signs of them. But what you're doing there is you're subtracting, but both of them will switch signs. The highest power of w should cancel out, which it does here, right? So the w squareds are going to cancel out, and then I combine these together, and I have a 42w left over. And then one more time, sorry the line went kind of crooked there, bring the next term down, repeat this process one more time. What do I multiply to 6w to get 42w? I multiply by a 7, a positive 7. 7 times 6w gives me 42w, so I match that first term. 7 times 3 gives me positive 21. Then don't forget, you change the sign, you subtract these, so these both become negative. All right, you change the sign of both of them, so they both become negative. The highest power of w cancels out, and we end up with a 4 left over. And there's nothing else we can do here. There's no more terms to bring down. This won't go any more into 4. So this would be my remainder. All right, so this is your remainder here. And up here, this is your quotient. So what you do to put it all together is you take your remainder and you write it up here with your answer, but what's happening, you don't put R4. That's what we used to do like in elementary school or maybe even in high school, I don't know. But it's a really bad idea, I think, because it doesn't tell you how the 4 fits back into the problem. So we have this remainder of 4, which never made it out of the division. It's still stuck under here, still being divided by the 6w plus 3. So what we do is we add it to our answer, 4, still being divided by 6w plus 3. So whatever your divisor was goes in the denominator for that. And that's how it relates back to the problem. All right, let me try that again here. All right, so this will be my final answer. Now I left it off on purpose, but I believe this problem was multiple choice. So you should be able to look through the multiple choice options and find the one that matches find the multiple choice that matches the answer that we got. Okay, so that's long division. Next problem. Here it's another division problem, but this one we can do by another shortcut called synthetic division, which only works, and it's unfortunate they're using the letter C here because it's in the formula I'm about to give you, but it only works if you're dividing by x minus c. Right? So as long as it's of this form, then we can use synthetic division to do the division. And that's exactly what we're dividing by here. So we're dividing by just the variable, either plus a number or minus a number. Right? So the way synthetic division works is you set it up like this. It's a little bit different contraption. You identify the number c. I'm not talking about the variable we have here. I'm talking about this value for c from this formula, which comes from this number here, the number in your divisor. What you have to remember is whatever that number is, what you want to use for c is the opposite sign of that number. So here we have positive 4, which means my value for c will be negative 4. So I'm going to put a negative 4 here outside the box. And then across the top inside the box, we write just the coefficients of the dividend, starting from the highest power going down to the lowest power. So it's going to be 4, 19, 11, and negative 10. And that's what makes this a shortcut, because we're just focusing on the numbers. We're able to leave the variables out of the picture because the numbers follow a very specific, predictable pattern here. So we can just focus on that pattern and not worry about the variables matching up. They just kind of automatically do if we follow this process the right way. So to get the process started, we take the first number inside the box and then drop it below the box. So we just drop the 4 straight down here. And this is where our answer is going to show up. So 4 is the first number in our answer. We take the 4, we multiply it to c, right, to this number here. So 4 times negative 4 gives me negative 16. You write the result underneath the next number inside the box, and then you add this column of numbers together. So 19 plus negative 16, that's just 19 minus 16, is going to be 3. And you just repeat that process until you get to the end. 3 times negative 4 is negative 12. Add this column together, you get negative 1. Negative 1 times negative 4 is positive 4. Add this column together, you get negative 6. And so we've divided, right? So that's pretty easy, right? It's easier than if we had done long division. But this answer can be a little confusing, right? Because it's just a bunch of numbers. What does it mean? The last number you get is your remainder. So the remainder was negative 6. All the numbers in front of that are going to be your quotient. But the variables are missing, right? We took the variables out of the problem at the beginning, so we have to put the variables back into the problem at the end to get our answer. And the way it works is just like it does up here. It's going from highest to lowest power, where the last number is going to be the constant term. So the last number is just the constant, negative 1. The number in front of that is the coefficient of the variable to the first power, which in this case, make sure you're using the same letter in the problem. It's c. And then this is going to be the coefficient of c squared. So it's going to be 4c squared. And if there was another number in front of that, it would be c to the third power and then c to the fourth power. So just kind of, I like to start from the last number and work my way back up. But it will go from lowest to highest if you do it that way. Since this 3 is positive, we should put a plus sign in front of it to make that a term. So this is going to be my quotient here. All right. And then I'll add to that my remainder, which is negative 6, which is still being divided by not negative 4, but the divisor, the whole divisor, which is c plus 4. All right, so make sure you use the actual divisor from the problem, not just the value of c, which was negative 4 in this case. All right, so that's how synthetic division works. It's a handy shortcut. However, if you don't like it, you can always just do it by long division. Math Excel's not going to know the difference, how you actually got the answer, and I'm not going to take off if that's, I'm not going to subtract points if you did it by long division. However, I will caution you that when you take college algebra, there is a couple of chapters, not chapters, there's a couple of sections in that course where you're going to be doing multiple divisions in the same problem, and synthetic division is just a lot nicer way of doing the division instead of long division. So it's something you're going to want to learn eventually. All right. So these problems, this whole chapter, so when you go to take this test on chapter 5, it's a little bit longer than the other tests. The number of questions isn't too bad. It's just the content. The problems are kind of lengthy. They take a while to get through. So just be ready for that. You might be spending a little bit extra time more than you're used to. This is called a complex fraction because you have fractions. It's an overall fraction, right? Where this is the numerator of the fraction right here, and this is the denominator down here. But within the numerator and the denominator, we have little fractions. So you have fractions inside of fractions. That makes it a complex fraction, which is not a good thing to have. So what we want to do is make it an ordinary fraction. Instead of being complex, where you have fractions inside of fractions, I just want one thing on top and one thing on the bottom where there's no fractions inside of the thing on top or inside of the thing on the bottom. So I hope that made sense. So the way you achieve that, there's a nice, easy process to follow. You find the common denominator of all your little fractions, right? So we have, I'm just going to mark this one up a little bit more. So we have y, we have z. Those are the denominators on top. We have y and z on the bottom. We find the common denominator for that, which is the LCM. And again, don't overthink it. It needs to be factored, but these are too simple to factor, so these are the factors. And so the only factors you have is you have y and you have z, right? Y is a factor in these denominators, z is a factor. Raise each one to the highest power. They're all to the first power. So the common denominator is just going to be yz. And then what you do with the common denominator, there's a couple paths you can take. This is the process I prefer. There is another way to do the problem, but I'll leave that to you to look into. It'll be on Math Excel if you want to look at the other method. I take the common denominator and I multiply it to the top and bottom of my big fraction. So I'm going to multiply the LCM to the top and I multiply the LCM to the bottom. And then you'll distribute, so it gets multiplied to each fraction here. If I can draw my arrows well enough. All right. And so what we're going to end up with is we'll have 3 over y times yz plus 9 over z times yz. All right, so that's what we end up with on top. On the bottom, we're going to have 6 over y times yz minus 2 over z times yz. Right? So the LCM gets multiplied to every term on both the top and the bottom of the big fraction. And you can think of these as being over 1 if you want to kind of line it up with the fraction a little bit better. And what should happen if you pick the common denominator correctly is the fraction should go away. The common denominator should somehow cancel out with the regular denominator that we have down here. And if the regular denominator cancels out, it's not a fraction anymore. Right? So I don't know, I didn't say that very well. So let me try saying it again. The common denominator should cancel out all the individual denominators. That's just an easier way to say it. So for example here, this y is going to cancel out with this y. And so the denominator is gone, so it's not going to be a fraction anymore. So what are we going to have left over? We have a 3 here, which gets multiplied to the z, so we get 3z. Over 1, which we don't need to write, because if you're dividing by 1, it stays the way it already is, right? So 3z divided by 1 is just going to be 3z. Plus, here, the z's are going to cancel out, and I'll have 9 times y left over 1, which is just going to be 9y. Right? When you divide by 1, it doesn't change. On the bottom, we're going to have the y's cancel out again here, and we'll have 6z, right, minus, because there's a minus on here, the z's cancel out in this case, and we'll have 2y. And there you have it. Now, you should maybe consider the possibility that these would cancel out, but they don't. I mean, you could factor out a 3 here. I mean, so, technically we should check, but I'm sorry, I'm being kind of lazy. You factor out a 3 on top, you can factor out a 2 on the bottom, and you see that nothing matches up, right? The 3 and the 2 aren't going to cancel out. These factors aren't the same, so nothing reduces, so you can just leave it like this. But it's still a fraction, but it's not complex, right? It's just an ordinary regular fraction now. So that's what we're trying to accomplish here. Okay, let's try the same kind of problem here, but just a little more complicated, right? So here, the denominators are a little more complicated. So the LCM, the common denominator, is going to be a little bit more complicated. So the LCM in this case is going to be, first you want to factor all of your denominators. I'm going to write it down here actually. I'm going to mark it up on this. Z plus 7, Z minus 7, Z minus 7, Z plus 7. So you want to have those factored first. On some of these problems, you might have something to do there. So you might have something that can be factored. For this example, these can't be factored. They're too simple. So they are the factors in these denominators. So my factors here are z plus 7. That's a factor that occurs in these denominators. And z minus 7. And that's it. Right. Nothing else happens in these denominators. So like I said, in some other problems, you might have to factor these things first and then do the LCM after you factor it. You take the LCM and you multiply it to the top and the bottom of the big fraction. So I'm going to multiply z plus 7 times z minus 7 on top, and I'm going to multiply z plus 7 times z minus 7 on the bottom. Now, in the last example, I wrote out in a little bit more detail what it looks like when you multiply the LCM and you distribute it and you multiply it to each fraction. I normally don't bother writing out that much, and I especially don't want to do that here because there's just a lot more to write. I prefer to do it mentally. So think of this as being over 1. Same thing on this one down here. And let's just mentally try to calculate what's going to happen when this gets distributed to both of these so that we don't have to write it out and we can just write the result instead. So what's going to happen when this gets multiplied to the first fraction is the z plus 7 down here is going to cancel out with the z plus 7 right here. And what's going to be left over is I'll have a 6 left over times the z minus 7. Now I don't want to leave this crossed out because a fresh copy of this has to get multiplied to the next fraction. So I'm going to undo my crossing out. But just keep in mind, that's what's going to cancel out in the first case. So what's going to be left over is just the 6 and the z minus 7. All right. So let's undo my crossing out there. So I'll have a 6 left over times a z minus 7. The z plus 7s would have canceled out. Now I'll have a plus sign. And then a fresh copy of this has to get multiplied to the second fraction. What's going to cancel out there are the z minus 7s. This z minus 7 is going to cancel out with this z minus 7. So what am I going to be left with? I'll be left with the 7 that was here to begin with times the z plus 7 that's left over from my LCM. So that's what's going to be left over when these two get multiplied together. Right? So again, I'm going to undo my crossing out. But again, mentally, keep track mentally. The z minus 7s cancel out. So what I'm left with is a 7 times the z plus 7 that'll be left over. And that just saves you a lot of writing if you could do that. So you do the same thing on the bottom. We're going to distribute to each fraction. The first one, the z minus 7s are going to cancel out. So I have the 7 that was here to begin with, and then the z minus 7s cancel out, so I'm going to have a z plus 7 left over. Minus, because there's a minus sign here between these two fractions, a fresh copy of this gets multiplied to the second fraction, and in this case, it's the z plus 7s that are going to cancel out. So I'll have an 8 that was already here to begin with times the z minus 7 that's left over from the LCM. And so it's a lot of work, but we finally turn this into an ordinary fraction, but we can't leave it like this with all these parentheses. So we want to distribute and combine like terms and then see if we can reduce, which again, 90% of the time you can't, but this might be one of the exceptions again. All right, so we'll distribute all this stuff. We'll end up getting 6z minus 42 plus 7z plus 49 over, on the bottom we're going to get 7z plus 49 minus 8z plus 56 because we have to make sure we distribute the negative sign with the 8. All right. And so we combine like terms here. Let me make the equal sign a little bit nicer. Combine like terms. And so we end up with 6z plus 7z, that'll be 13z. Negative 42 plus 49, that's going to be plus 7. That's a good sign because that doesn't factor, so very unlikely that this will even reduce. On the bottom, we get 7z minus 8z, which will be negative z. And then 49 plus 56, I don't have a calculator handy. That's going to be, well, 50, and that's going to be 105? I think it's going to be 105. Hope I'm not wrong on that. All right, and since neither one of those factor, nothing can be reduced. So that will be my final answer. All right, so that's complex fractions. So I might need to split this up into 2 videos because this is kind of like the halfway point, to be honest. So, sorry, didn't mean to mark right there. Let's see what the next problem is. All right. So now we're solving equations. So maybe what I'll do is pause for now. I kind of need to take a little bit of a break myself. We're kind of hitting the hour mark, which is normally my goal for these videos anyways. So we're halfway through. We'll do the other half of the practice test in part 2 of this video.